Welcome, everyone. My name is Larry Pearson, a Vice President at Impetus Technologies. It's my pleasure to be your host and MC for today's session entitled Ensure Successful Data Ingestion on the Cloud, Strategies for 2021. So here we are, it's December, and 2020 is almost behind us. For many reasons, we're all looking forward to that, but that means it's time also to begin to look forward and do some planning for 2021, and I hope today's session will be very helpful for you as you do that. For those who may not be familiar with us, Impetus is a group of companies headquartered here in the U.S. in the heart of Silicon Valley, and we specialize in this whole topic of analytics and migration to the cloud. And I've got a couple of excellent thought leaders with me today to help with that, who I'll introduce here in a moment. But before I do that, let me cover just a few housekeeping announcements. All of our attendees will be on mute, but you can at any time during the webinar ask questions through the chat panel there on your screen. And that's one of a couple of different ways we try to make this an interactive experience. And we have set aside time at the end of the webinar to answer all of the questions that come in. If we cannot answer all of them live and on the air, we will do that back to you in email. So any question that gets asked will be provided an answer, and encourage you to send your questions in at any time. If you have any issues with the audio or video at all, you can reach out to our ops team by sending an email to events@streamanalytics, and that's STREAMANALYTIX, streamanalytics.com. Let's take a minute now and look at the agenda for today's topic. I'll go over, after this introduction, we'll talk about the current state of cloud adoption with regard to data ingestion, and then talk through a next generation platform for doing data ingestion on the cloud. That will be followed by a demo showing a data ingestion modernization using our product Stream Analytics. And then we'll summarize and wrap up with some key takeaways, and then go to questions and answers at the end. Another way that we make this an interactive experience for you is to have a couple of polls. And I'd like to execute the first poll now. You'll see that on your screen. And the first poll says, what does your cloud data ingestion report card look like today? And there's four options there. One, we're in production, our business goals have been achieved. The second one says siloed IT is posing challenges to cloud adoption. It's another big issue that we work with our clients to help solve. Evaluating various options on the cloud, or have started running an assessment or POC on data ingestion on the cloud. So again, take a few minutes to answer those, and we'll come back or to respond to those. We'll come back here in a few minutes and share with you the results of that poll, and thank you in advance for participating in that. Now, let me introduce a couple of my colleagues who will be assisting today on this webinar. The first is Samir Baide. Samir is Director of Technology for the Stream Analytics product offering. He leads the product engineering efforts. He's responsible for analyzing market requirements, for managing the roadmap, and designing a product that meets the business challenges in devising appropriate solutions for our customers. Also with him is Saurabh Dutta. Saurabh is a senior solutions architect, and Saurabh was one of the very early team members who helped develop Stream Analytics, and brings a unique blend of both business and technical knowledge, working with customers to achieve their objectives with regard to this topic. So what I'd like to do right now is invite Samir to get us started by kicking this off. Samir, jump right in.
Thank you, Larry, for the introduction and setting the context. Welcome, everyone. I want to begin by saying that this year we have witnessed a big leap in cloud adoption for enterprise use, and this is especially true on the SaaS and the managed services side. To put things in perspective, the cloud market is positioned to grow over $1 trillion in the next 5 years. and companies will continue and expand their cloud footprint to derive benefits of scale and elasticity offered by cloud services. However, as a first step towards this goal, organizations need to start getting the data first on the cloud. However, with increased spending and pressure to deliver, IT runs a huge risk of wastage in terms of time and material, non-starters, or projects and initiatives that never reach the next level of adoption. And wasted spends amount to an alarming 20% of all cloud spends every year. The kind of investment and initiatives undertaken for cloud migration, we have witnessed a paradigm shift that has shaped how companies approach cloud migration in general. And 2020, in that regard, has been pivotal in the area of cloud ingestion. One of the biggest things that has materialized both in terms of adoption and availability is basically emergence of SaaS-based turnkey offerings. Now, there are multiple cloud native services as well as SaaS managed services for automating data migration. The other thing that has bridged supply and demand on the talent side, especially in cloud and big data analytics space, is skill set normalization. Now, this is fueled by the ability of modern upcoming platforms and services in that they don't require any specialized administration or technology skills to be able to operate in the cloud, which is a huge leap forward. One of the most powerful enablers in this set of paradigm shifts is the new approach to application design and development. The low code or the no code approach is about creating complex applications, making it possible for application developer to focus on business logic and KPIs that they want to implement. For instance, for data ingestion, you would want to focus on schema, curation, and let the platform worry about boilerplate code for things like scheduling, bad data handling, how data is acquired, how it is processed. Now, these paradigm shifts are brought about by development of new information architecture and the realization that the current solutions are inadequate for the type and volume of data that we're expecting in the 5G era. Similarly, there's been a shift in consumer priorities as well. In our case, we see expanding analytics use cases on a variety of data types and data stores that require on-demand scalability as well as better cost controls. Now, given this paradigm shift, where do enterprises stand with their data ingestion initiatives? And what's the real current state of affairs? To put things in perspective, we do see that our clients and customers and increasing number of small and large enterprises in general have made a strategic decision to adopt cloud. They've either already started leveraging some cloud services and they have laid out plans to modernize their information architecture. From a tactical standpoint, IT teams have been experimenting with SaaS solutions from various providers, and they're doing proof of values, proof of concept on multiple managed services. We also see committed milestones in terms of what percentage of data or workloads organizations want to move in the cloud in the next couple of years. Organizations have also set goals to become completely data-driven. In that, they aim to establish a single source of truth in the cloud, which is extremely complex. They also want to use advanced analytics services offered by the public cloud infrastructure. Additionally, one of the main IT goals is to create an architecture that decouples application and information architecture from the underlying platform services. There is also an immense push to employ multiple clouds and hybrid cloud strategies, and at the same time eliminate the use of multiple legacy systems at play on-prem. Lastly, from a cost management perspective, upfront investment is getting discarded in favor of pay-as-you-go model. As organizations progress in their cloud journey via either proof of value, internal assessments on cloud migration, certain key learnings are discovered. For example, it is absolutely clear today that none of or not all of the data will be in the cloud. Some data will almost always need to be processed and computed at source. Hence, having a hybrid strategy is absolutely critical. Then again, transitioning of data, managing copies, and achieving a single source of truth in the cloud is challenging as well. And typically what happens is these aspects tend to be overlooked in isolated migration POCs. And to take these things into production, this is where organizations struggle a lot. The other place where we see a lot of enterprises struggle is with custom-built frameworks that are managed by small IT teams with very little governance in place, especially around things like data lineage, lack of practices around data stewardship, and not having solutions that operate as part of a larger enterprise architecture. Now, this basically leads to operational issues, and these things either have to be addressed first or have to be undertaken as part of an architecture modernization initiative. One of the biggest learning out of this exercise is to create an architecture that is agile toward business needs, is open to extensions and new use cases, and at the same time is not bound to any cloud vendor. So what does it really take to implement a powerful data ingestion strategy? And what should be the desired state for IT and business to handle the challenges that we mentioned previously? From a technical standpoint, the architecture should be extensive and provide out-of-the-box components for connecting to a wide variety of data sources. These data sources could cater to structured data, unstructured data, coming at different times, different velocity. All of those variations need to be handled and made available as part of the platform. Feed management is another critical capability. Things around feed management include administration, schema management, and versioning. These are absolutely critical when you talk about supporting a large number of data sources. The platform should also allow users to focus on solving business problems and using a methodology of low code and extreme automation. And when I say automation here, I'm referring to plug and play reusable implementations of commonly used ingestion patterns as well. From a business standpoint, self-service is the key. Different type of users, whether they're analysts or operations or developers, these users should be able to get started quickly and easily on the platform. The ingestion strategy should be platform neutral as well. It should take into account the changing landscape of the services offered in the cloud. And this strategy should also take into account how different business units will share costs and how cost controls will be realized within the organization. Organizations today operate as a one large organization. They have different business units, and the cost control and chargeback also has to be managed. Let's take a real-world example of how we transitioned the ingestion architecture for one of our large US telco customer. Now, this use case is a combination of architecture modernization, cloud migration, as well as workload migration. To give you a high-level overview of the problem domain, the customer is basically receiving a large number of data feeds from different frequency coming in various formats from SFTP servers. So they're getting basically a set of records which are zipped and contain different formats on their FTP sites. Now they then have a custom homegrown ETL, which is basically applied over the data after it is ingested. The data is then fed to an enterprise data warehouse where it is stored as raw data. And then another set of ETL running on the enterprise data warehouse makes that data available for upstream systems. As part of this problem domain, the key challenges that the customer wanted to address were, first of all, feed management, which requires, from their standpoint, they needed versioning. They wanted a way to manage metadata, as well as they wanted the ability to separate metadata from the actual source. So whether the data is coming from FTP or some other source, they really wanted the ability for data stewards to be able to control the metadata of that information. Secondly, they also wanted to have a clean managed landing and staging area to enable ease of operations, which was not possible in this scenario. As part of the modernization initiative, they had a custom ETL with which only basic things were possible. And they wanted to modernize the processing framework so that they could be able to scale based on data characteristic changes as well and the business demand. They also had a huge data reconciliation logic, which they wanted to standardize as an SCD type 2. Overall, they also wanted that the new solution be flexible, should lend easily to multi-cloud and hybrid infrastructure. Let's take a look at the high-level solution that was developed. In order to implement a solution that takes care of all the challenges of the problem domain, we use Streamatics platform. Now, this was done to provide feed management, out-of-the-box ingestion scheduling for FTP and other sources as well. We also created automated managed landing areas with optimized storage. On the ETL side, we used a web-based designer to recreate and reuse some of the existing ETL logic, and also use a data-driven approach to create data quality rules, which was very complex in the existing architecture. Finally, a staging area was reconciled into the cloud data warehouse. In this case, it was Amazon, so we were using Redshift. Here we used a type 2 SCD for data reconciliation. Again, the ingestion application was managed and scaled automatically using Amazon EMR. We also had an option of using Databricks without having to change anything in the application. So whatever information architecture we create, that was runnable across a variety of compute infrastructures. Now, moving to cloud and adopting a modern architecture had many advantages. The highlights of the solution were we were able to create and onboard an application in 2 weeks, as compared to an original estimates over 6 months. So essentially, we had more than 10x faster deployments. This was made possible by a combination of data-first approach, low-code methodology or zero-code methodology, and a great big library of out-of-the-box components for ETL. We also saw a gain in performance of over 3x. The ETL logic that a user designs on the UI in Streamatics is capable of running at scale on either Amazon EMR, Dataproc on Google Cloud, Azure, and Databricks as well. Similarly, the data warehouse can be switched to a separate data warehouse provided by Azure or GCP. Essentially, the application that was created could easily run on any other public cloud. With intelligent tiering and compute optimization, the cost benefits were significant as well. To see a demo of Streamatics in action, we take an example use case to show problems like this, where we describe how they can be easily solved. But first, I'll turn it over to Larry for poll results. Over to you, Larry.
Thank you for responding to our poll. You'll see the results here on the screen, and they are quite interesting. It looks like as many as 40% of our audience today are evaluating various options on the cloud, with another 50% either wrestling through some challenges getting data ingestion operationalized on the cloud, which that 25% or in the early developmental stages of assessing how best to do that. And just 10% have actually fully operationalized a data ingestion strategy for the cloud and have, as our poll offers, achieved their business goals with regard to that. So thank you again for responding to our poll. And I'd like to now invite Saurabh to come on, who will give you a demonstration of the Stream Analytics solution platform.
Thank you, Larry. So now, with the background of the current scenario of the ingestion landscape, I would now like to demonstrate an offering by Impetus, which is called Stream Analytics. So Stream Analytics is a self-service data flow and analytics platform. And here we are emphasizing heavily on simplification. And one of the focus areas that we have inside of the application is definitely ingestion. And we have built-in application specifically around ingestion that I'm going to focus today. So the idea really is to simplify the complex process of ingestion, and that's where we have actually incorporated multiple enterprise ingestion patterns inside of this application. So this is something which is very unique to our platform, which you will not get in most of the tools which are available in the market today. Most of the tools have very basic ingestion where you can move data from one source to destination with maybe in certain cases apply very limited transformation. But we all know that in real life, the entire process of ingestion is not that straightforward. And often you have multiple steps that come in picture when raw data has to be prepared and prepared for consumption, and then it has to be available in the data warehouse. So let me just share my screen and take you through the demo of the application. Yeah. So in the next few minutes, I'll just showcase the capabilities that we have around ingestion in Streamatics, and you can see there are actually multiple different functionalities and capabilities of the platform. But for today's demo, I'm just going to focus on ingestion. So let's first start with something called as data sets that we have in the platform. So these are nothing but typically you read data from files or tables, etc. And what happens is we get these feeds in a very raw form. So through data sets, what we want to enable is we want to provide a curated source over here. So before you make your data available for collaborative development, data stewards could actually come and curate this data, and they can standardize this data so that now when you build the pipelines, you have a much cleaner and a standard data set to work on. So in this example today, there are multiple data sets that are already created. I'll just use the web sales data. Yeah. And we'll just use the web sales data over here. You will see that this was created some time ago, part of the demo project. I'll just look at some of the details. So when I go inside this data set, I'll instantly observe that the curator has actually took S3 as the source, and we can see the bucket, the format, what are the different columns that were used to create this data set, and additional information like tagging and some description could also be provided. What's also interesting is when you work on this data set, as you keep cleaning and as you keep working on this data set, you can also create versions over here. And when a particular version of data set is being utilized or used in Streamatics, you can also see the lineage. So here in this example, we can see that this web sales data is used by a demo project and used by a particular application. So we can see how my data is actually used. If it was changed, we could also see how the data was getting changed as well. Now, at the same time, when we can just add information to this data, but the more important feature is how you can now work on this data. So this will just take a moment. Yeah. So now the data is read from the live source, and it is rendered over here. We can see that we have 35 columns, and a couple of them are listed because this is data from e-commerce web sales data. You can see that it has typical fields like what was sold, when it was sold, customer details, shipping details. So all this information is part of the incoming schema. Now, let's say if I have to clean this or apply certain rules, I can do it right here. So let's say I have my billing amount and I want to just add certain value. I could say that this, let's say I want to just filter the data wherein the amount is greater than, let's say, $500. So I would just apply that filter right away, and all the records, this rule will be applied on all the records, and you will see that an additional filter is applied where the amount is now greater than 500. So that's how multiple rules are created. And additionally, I can also see certain statistics of the record. So right now, if I just choose one column, the application will analyze and generate certain statistics for me. This kind of gives me a holistic view of the data that now I'm going to work with. That's step one. So I have my data source ready. Now I can go ahead and create my ingestion app. So I go to the applications tab. I already have an ingestion application created. So what's important over here is, as we were talking earlier, that here we are not just limited to one source to target. We really can customize this depending on my need, whether I want to read the data and get it into the landing zone, or I want to also transform the data, put it into staging. If I have a customized data warehouse, I could just load the data there as well. So I can really choose the steps that are required in my ingestion flow. So for this demo, I'm just choosing all the steps. So now the next step is I now can choose from the curated data sets that I have. I can definitely create my own as well, but when we have these kind of standard data sets, it really becomes easy. So I know that this is a reliable source of information which I could further process in the pipeline. So before I move forward, I will just check, if this is the right data source I'm looking at. I can just verify the schema as well. And if there is a need, maybe the data set was created using S3, but if there is a need, the same schema could be applied to some other source as well. So imagine the feed is coming from SFTP. I could just choose SFTP and apply the same schema on SFTP as well. So that's how I configure the source. If there is a need for incremental read, I could do that. The next part is configuring the landing zone. So this is again where my raw fields would typically land. I could again, provide relevant configuration. In this case, it is S3. I could just provide the bucket time path and how I want to create the data. This case, it is a delimited file that is getting generated. Once I have my data in the landing zone, next step is when I actually transform the data. So here is where you could apply very complex transformation before even you push your data into staging. So from feed to landing zone, I have the raw data in place. And after I transform this data, in the staging zone, I'll have the cleansed data that can be used. So when I land to this interface of transformation, you will see that a very beautiful graph is represented over here. This is what we call as our data prep plane. So here you will see again all the records that are coming in. I could actually select certain ranges of values which are auto-populated, and I could see that how it is now related to the other attributes that are coming in. So here also I could perform data preparation rules, but maybe, since we have already a curated data set, I can avoid it at this stage. But imagine you were reading directly from the source, all the data prep rules could be applied here as well. Here what we are doing is now we are applying certain data quality checks. So imagine, you have null values or empty records, or let's say data which is not in valid ranges that is coming in. So you could apply all those kind of data quality checks over here, and you can also configure what you want to do with this data. So in this case, we have applied data quality checks, and then we are pushing this to an error queue. So once you have the data in the error queue, you can then think of what you want to do with that data next. You may just want to reprocess that data, or you want to discard it. It's up to you. But that is how you could, let's say, perform data quality. Similarly, one other example of data transformation is you could create derived attributes. So in this case, based on the billing address, we are just identifying whether the shipping zone is 1 or 2. And this is just a sample transformation. But what's important is we have an array of various kinds of different transformations that you can now apply on the incoming data before the data is pushed into staging. Next, we have just again, we have just pushed this into a staging zone. And from here, you could configure where you want to stage your data. So again, just to keep the example simple, again, the staging zone is also S3, and you could in the same manner choose a bucket, choose a path where you want to push the data into. And one important thing is now you can also do SCD over here. So we have an option of choosing SCD at staging as well. And finally, when you push the data into target, you can choose SCD there as well. Just uncheck this. And when I move to the target, here also you can take care of all the changing dimensions. You can define your STD rules here as well. So that's how the data passes to various stages, and finally you can have it into some sort of an enterprise data warehouse. The final step is how frequently you want to schedule this process. So end to end, if I look at this, from source to target, you can define your rules using a cron-like expression, and this will be executed on a need basis. Now, you have seen how we have created this application very simply, just by going through a wizard-like process. So again, once you have the application created, we also have an end-to-end ETL interface, which you can again use to now process the data, let's say from the data warehouse. I'm not going into those details today, but the idea really which we wanted to show in today's demo was we really have simplified the entire process of ingestion. With that, let me just go back and let me just summarize the key benefits of this approach. So as we have seen, you can actually manage the end-to-end life cycle of even the most complex workflows very easily. And this includes data acquisition. You can customize your application further by adding complex transformations. And also, finally, it also takes care of the operations like scheduling or error handling, etc. So ultimately, what we have seen is really in today's demo, it was really a no-code environment where most of the ingestion use cases could be accomplished very easily. But at the same time, you can also add code. And even for complex scenarios where there is a possibility of where there is a need where you cannot achieve these using a simple out-of-the-box transformations, you could just write your own code and get the ingestion application accomplished. One other thing is the platform leverages native cloud infrastructure components. So Streamatics can scale along with the underlying infrastructure components. So it has built-in capability of scaling. At the same time, you could also define auto scalability rules that can be very easily configured over here. And finally, as you have seen, we have provided support for data reconciliation both at staging and target layer. So if you just had to create a data lake using S3, you could define your SCD rules there as well. While if you want to push it into a data warehouse, you could define your SCD rules at the data warehousing layer. And finally, we support all the major cloud vendors like AWS, Azure, and GCP. So that's all I wanted to cover today. And I'd like to thank you all for taking out time today to attend the session. Over to you, Larry.
Thank you very much, Saurabh and Samir, for that excellent overview of our topic today and for your demonstration, Saurabh. That was very interesting. We have had some questions that have come in, and we'd like now to move to addressing those. Thank you for participating that way. Following the treatment of the questions here, you will see another feedback screen and another poll that will give you the opportunity to rate your experience here today and also offer some comments that we take very seriously, and we'll use those to improve the future user experience for others that might attend. But you'll also have the opportunity to request a deep dive of the product as you've seen it in the webinar today. So let's focus now. You'll see that here in a minute. In the meantime, let's go ahead and address the questions that have come in. The first question that came in says, throughout the meeting, I see the source for data ingestion as FTP site flat files in S3 bucket, etc. Do you guys have the capability to connect to the actual source, for example, Oracle, and pull changes based on changes in a traditional CDC tool approach? And Saurabh or Samir, which you would like to address that?
So thank you, Larry. This is a great question to have. Actually, we do have, the way you saw the ingestion application, we also have what is called as a CDC application that allows us to read directly from sources like Oracle. And even within that, there's a variety of ways in which we can do that using using third-party adapters as well as native approach to reading data from Oracle. Again, it still is based on the same philosophy. You don't actually have to write any kind of code to create a CDC application in Streamatics. You can, just as you saw this application, you just are presented with a wizard that you can configure, and basically you'll see a CDC application getting created. You can manage the scheduling as well as the performance of the application and choose and select rather from a variety of data streams that we support to offload your Oracle data.
Okay, excellent. Samir, here's one for you. Can you ingest data into Snowflake as a destination or target warehouse?
Oh yes, we do support Snowflake in a variety of ways. Streamatics has a native integration into Snowflake where you can read data from Snowflake warehouse. You can even use Snowflake as your data sink, as well as you can register Snowflake tables as your reference data. If you have a data mart built into Snowflake, you can look up Snowflake data on demand as well as part of a ETL application.
Thank you, Samir. There's also a question here about, is it possible to write proper Python code in Stream Analytics?
Oh yeah, so Streamatics has integration with Python. We actually support Python 2 and Python 3 environments, where basically if you're writing an ETL and there's a functionality for which you already have an existing Python code, or you wish to write native Python code in addition to the drag and drop functionality that we have. We have an inbuilt Python processor, as we like to call it, that can be used to either write your code in line, or you could upload your Python EGG packages and make that Python code as part of your ETL platform. We also support notebook integration within the platform, so you can do pretty much any programming that you want to do as part of your Python kernel inside of your notebook that Streamatics supports. So we support Python in a variety of ways.
Excellent. Appreciate that. Saurabh, I've got a couple here that have come in that you may be the best to answer. The next one says, what type of custom logic can you plug in during the transformation stage?
Yeah, there are actually multiple ways to add custom logic in the platform. You may just, add your custom logic in form of languages like Java or Scala. If you are comfortable, as Samir mentioned, with Python, there are a number of ways in which you can integrate Python-based code. We also support scripting in the platform, so it could be a simple expression that you can provide while you are creating your transformations. And similarly, there is also a way to give SQL in the pipeline. So it really depends on what kind of language or the way you want to implement custom logic. There are a number of ways to do that. It really depends on your choice.
Okay, great. Saurabh, there's another question here that says, what data formats are supported on the data source side?
Yeah, I think most of the enterprise data formats are supported in the platform out of the box. Actually, it includes things like JSON, CSV, Parquet, even the modern formats like Avro or ORC. All of these are supported. We can actually not just the ones which are available out of the box, but with a lot of customers, we have also encountered very tricky custom formats as well. So we can always extend our library of the formats that we support to even support a very specific format of data that is coming in. So really you have all those hooks available in the platform.
Excellent. Well, listen, that answers all of the questions that came in. Thank you, audience, for that. Do take the time to rate your experience today, and we would invite you to take advantage of the opportunity to experience a deep dive of the product as shown in the webinar. When we do that, we actually are able to tailor that specifically to scenarios, use cases, examples that you'd like to use, and we'll get with you and understand what that looks like and make sure that then the deep dive example that we host for you will be very, very contextual to the things that you are wrestling with. I want to thank you all for participating today. Have a great balance of your day. That concludes our webinar.